So another past paper question. In this video, I will tell you what should be the distance time graph and the acceleration time graph of a bouncing ball, and especially if the ball bounce is elastic, means no energy is lost, which means the ball will retain its original height after bounce. Okay, so let's first understand the diagram, that how the velocity was changing actually. Okay, because once we will understand how the velocity is varying, that will give us idea to draw the position time graph or the distance time graph. Okay, so let's start from here. Let's say this is a ball that is just released from the 2 meter of the height, and when it is released, so it means that its initial velocity is 0 meter per second. But what will be its trajectory as it is falling freely? Okay, so it means that it is accelerating uniformly. Okay, so it is moving like this, and this is just before hitting the ground. Okay, so we see at initially in the beginning there is a no velocity, but you see that the velocity is increasing, and I give you the reference which equation tells us that the velocity increases. So that is the vy is equals to vy0 minus gt. So if you write negative sign of the g, so as the time passes, the velocity is increasing. So that's why at this moment it will have a more velocity, and just before hitting the ground it will have a maximum velocity that will be downward. Okay, now we know that the velocity is the slope of the position time graph. So it means that, can I say that it is increasing but negatively? So which means that the velocity is not constant, right? So when it is not constant, it means that the position time graph, or like in this question we are calling it distance time graph, will not, it can never be a straight line, because velocity is changing, which is the slope of the distance time graph and displacement time graph or the position time graph, which means that we cannot have the straight line graph. Okay, so then it should be curved. Now should it be curved like this, or should it be curved like this, or should it be curved like this? Okay, it depends. You should know that the velocity in the start is 0 and how the velocity is increasing. So the it is exactly matching the scenario. As you see that if I draw the tangent line, so the tangent line is becoming more and more steep, and in fact as the time passes the velocity is becoming more and more negative. Got it? So which means that our graph must be starting from some maximum position, because at the time t is equal to 0 the ball was at 2 meter height, so it should be 2 meter in fact, and this should be like this. Okay, and right at this point, dear students, you see if I draw the tangent. So I hope now you understand in much better way. At the time t is equal to 0, this tangent line is horizontal, velocity is 0, then velocity is increasing, and in fact maximum just before hitting the ground. Now this is the distance time graph, which is clearly written in the question, which means that this graph cannot go below the horizontal. It means that this graph must, the shape should be like this, and you notice that our, it will once again reaching the 2 meter of the height. Okay, so this is the graph of the bouncing ball. So option A should be the right answer.